Hello students, welcome to the math class. Students, today we are going to start a new chapter, that is trigonometry. Basics of this chapter you have already done in the previous classes also. So let's discuss its objectives. First objective is signs of trigonometric function in different quadrants. Second, domain and range and period of the trigonometric functions. Third is compound angle formulas and its application. Next, fourth is converting product into sum and difference of the trigonometric functions. Fifth, converting sum of trigonometric functions into products. Sixth is multiple angle formulas and its applications. Last one is a sub-multiple angle formulas and application. Today we are going to start with the first objective and then we will complete the second objective. Now let's start with the first objective. Signs of trigonometric functions. As we all know, there are 4 quadrants: first, second, third and fourth. Now, these 4 quadrants we are having different angles. In the first quadrant, angle lies between 0 and 90 degree. In second quadrant, angle lies between 90 and 180. In third quadrant, it lies between 180 and 270. And in the fourth quadrant, angle lies between 270 and 360. 2 pi means it is equal to 360. Now, functions have signs in the quadrants. So, we have to remember quadrant first. All the trigonometric function has positive sign. As you have already known that values of sine 0, sine 30, sine 45, then sine 60 and sine 90. When you calculate this value, you will get all positive values. So in the first quadrant, all the t functions are positive. Similarly for cos, tan, secant, cosecant and cot. Now, second quadrant is meant for sine theta and cosecant theta. Firstly sine and its reciprocal. So these two functions are positive in the second quadrant, except these two, all other are negative. So in second quadrant, positive functions are only sine theta and cosecant theta. Similarly, third quadrant, tan theta and cot theta are positive, all other are negative. Fourth quadrant, cos theta and secant theta are positive, all other are negative. We can remember it by this keyword, that is add sugar to coffee. Add means all are positive. Here sugar, S means sine and cosecant are positive. 2, T means tan and cot are positive. Coffee means C, cos and secant are positive. In this way, you can remember regarding the signs of the t functions in different quadrants. Now, you can see in the first quadrant, angles are like theta, or second it is pi by 2 minus theta. That is, you have done in the previous class also, that is the complementary angles. Now, look here, the signs of the t functions in the first quadrant. When first it is pi by 2 minus theta. Here angle will be pi by 2 minus theta. If we add the angle, that is pi by 2 plus theta, it will goes in the second quadrant because it will become 90 plus something. So it is greater than 90, so it goes in the second quadrant. So now look here. For the first quadrant, sine pi by 2 minus theta. Now remember one more thing. When the angle contains pi by 2 or 3 pi by 2, these are two angles, then function and sign change. It means sign changes to cos, cos changes to sine. This is the conversion of function and sign according to their quadrants. Now first is sine 90 minus theta. Here it includes the angle 90 degree. So here function and sign change. Now as sine is going in its own quadrant, so it is positive. So all the values will be positive. Sine 90 minus theta cos 90 minus theta is sine theta. Then tan 90 minus theta is cot theta. Cosecant 90 minus theta is secant theta. And secant 90 minus theta is cosecant theta. Cot 90 minus theta is tan theta. It is lies in the first quadrant. Now come to the second quadrant. There are two types of angles in the second quadrant. Firstly, when it becomes pi by 2 plus theta. Secondly, when it is pi minus theta. So two types of angles are there. So I have written their functions like this. First is sine pi by 2 plus theta. All angles will be pi by 2 theta. Now we have to remember that second quadrant is meant for sine and cosecant. It means these two functions having positive values, all are having negative values. Secondly, it is including pi by 2. So here function will also change. So first will become sine pi by 2 plus theta. Function changes to cos because it is in the second quadrant. It will be positive. So cos pi by 2 plus theta is minus sine theta. Tan pi by 2 plus theta is minus cot theta. Cosecant 90 plus theta is equal to secant theta. Then secant 90 plus theta is minus cosecant theta. And cot 90 plus theta is minus tan theta. Now look at the second type angle, that is pi minus theta. Sine pi minus theta, again it is in the second quadrant, so sine and cosecant will be positive, all other will be negative. Now as the angle includes pi, look here, pi only sign will change, function will not change, so they will remain same. Sine theta, cos theta, tan theta, cosecant theta, secant theta and cot theta. Only the sign change. First will become positive and cosecant positive, all other negative. Similarly, let's move to the third quadrant. Now in third quadrant, angle will be here pi plus theta, or from here it will be 3 pi by 2 minus theta. Now sine pi plus theta, cos pi plus theta, tan pi plus theta, cosecant pi plus theta, secant pi plus theta and cot pi plus theta. It means it lies in the third quadrant because here angle contains pi, so function will not change. So we will check their signs only. Now third quadrant is meant for tan and cot. So third quadrant is meant for tan theta and cot theta. So these two functions will be positive. So in front of tan plus sine and in front of cot it is plus sine. All other will be negative and function will remain same. Similarly, when it contains the angle 3 pi by 2 minus theta. Now 3 pi by 2, it is a line of 90 degree. So here function will change and sign will also change. Again we will see that for tan and cot it is positive and all others are negative because it contains 3 pi by 2. So function will change. Sine changes to cos, cos sine, tan in cot, cosecant in secant, secant in cosecant and cot in tan. Now for fourth quadrant. Fourth quadrant is meant for cos theta and secant theta. Now these two functions will have positive sign in this quadrant, all others will be negative. Now you can see from both the angles, two types of angles are there again. That is, first is here 3 pi by 2 plus theta and next is here 2 pi minus theta. Two types of angles are there. So we will consider the trigonometric function for both the angles. Now here firstly sine 3 pi by 2 plus theta, it will change into minus cos theta. Cos 3 by 2 plus theta, answer is sin theta, because it is a quadrant of cos, so it will be positive. Next, tan 3 pi by 2 plus theta minus cot theta, cosecant 3 pi by 2 plus theta minus secant theta, and secant changes to cosecant with positive sign and cot in minus tan. Now 2 pi minus theta angle, same thing, cos and secant will positive or other will negative. As it contains line of 2 pi, again function will not change. So sin 2 pi minus theta is equal to minus sin theta. Cos 2 pi minus theta is equal to cos theta. Tan 2 pi minus theta is equal to minus tan theta. Cosecant 2 pi minus theta is equal to minus cosecant theta. Then secant 2 pi minus theta is equal to secant theta, and cot 2 pi minus theta is minus cot theta. These are the all convergence based on the quadrant and the angles. Now next is periodic function. Now in periodic function you can see that when it completes one circle, it again comes to the first quadrant. It means its values start repeating after 2 pi. Now from here we can find that periodic functions, all the functions are periodic. It means they are repeating after fixed period. So here we can say that sin x plus 2 and pi, it means any multiple of 2 pi, any multiple of 360, it will again become same. So here sin x plus 2 and pi is equal to sin x. Similarly for cos, tan, secant, cosecant and cot. So from here we can say that period of all t functions is equal to 2 pi. Now with this you have to also see that one more thing, that is when the angle move above, that is in the anti-clockwise direction, we will take angle as theta, and when it moves in the downward direction, that is a clockwise direction, we will take angle as minus theta. So two types of angles are there, positive and negative. Now sin of minus x, when angle is coming negative, so answer is minus sin x. Tan of minus x, answer is minus tan x. Cot of minus x, answer is minus cot x. Cosecant of minus x, answer is minus cosecant x. Then when you see cos of minus x, answer will be positive. Secant of minus x, answer is secant x. From here we can see that for the first four we are getting negative sign and the last two is a positive. Now for the function we are getting negative signs, they are called odd functions. And the functions for which we are getting positive signs, so they absorb the negative sign, so these are called the even functions. Next is domain and range of t functions. Now domain means the values of x for which function is defined, and range is the answer value. So first of all, function is sin x and cos x. These two functions are defined for all the real values, so its domain is R. Next is tan x and secant x. These two functions are defined for all the real values except at the odd multiples of 90 degree. So it becomes infinite at the odd multiples of 90. So domain is r minus 2n plus 1 into pi by 2. Similarly for the secant x. Now last two functions are cosecant x and cot x. These two functions are defined for all the real values except at the multiples of pi. So here multiples of pi is subtracted from the real values. So cosecant x and cot x has domain r minus n pi and r minus n pi. Now range. Range means the answer values. Now as we all know, sin x lies between minus 1 and 1. Its values lies between minus and 1. So I have written the close interval. It may be -1 till 1. It may be 0, 1.5, any value will be there. Now next is for tan x, it is defined for all the real values, because at tan infinity, at tan pi by 2, it becomes infinite. Similarly, for cot x also it is defined and its value lies for all the real numbers. So R is there. For secant x and cosecant x, the answer will be all the real numbers except the numbers lies between the -1 and 1. It means open interval is there. Its value may be -1, its value may be 1, but not lies between these intervals. So R minus open interval -1 till 1. Now let's discuss some example based on these concepts. For example, if cos x is equal to -3 by 5 and x lies in the third quadrant. Now third quadrant means tan and cot are positive and all other are negative. So find the values of other t function. It means we have to find the values of all the other t function when x lies in the third quadrant. Now for third quadrant we have to remember only tan and cot will be positive. All other are negative. So from cos x it is -3 by 5. Secant x can be easily calculated by just taking the reciprocal. So 1 upon cos x is equal to -5 upon 3. Now next we are having sin square x plus cos square x is equal to 1. From here we can find the value of sin square x. It is equal to 1 minus cos square x. Now put the value of cos square x. We get 1 minus -3 upon 5 whole square. So on squaring it will become positive. So 1 minus 9 upon 25. Here when you solve by taking LCM you will get 16 upon 25. It is the value of sin square x. Now sin x is equal to square root of 16 upon 25. So when you solve it you will get two values, plus minus 4 upon 5. Now we have to reject one value. It depends upon the quadrant. Now as x lies in the third quadrant, so sign can't be positive. So value of sin x is negative, minus 4 upon 5. Next is cosecant x. That is a reciprocal of sine. So 1 upon sin x, it is equal to minus 5 upon 4. Now we are left with two values, that is tan x and cot x. Tan x is equal to sin x upon cos x. Put the value of sin and cos. Minus 4 upon 5, minus 3 upon 5. Here 5 cancel with 5, minus cancel with minus. So we are left with the value 4 upon 3. So it is a positive value. Similarly, cot x, it is a reciprocal of tan. So 1 upon tan, answer is 3 by 4. Now, let's take one more example based on the quadrants. Prove that cos x plus sine of 3 pi by 2 plus x minus sine 3 pi by 2 minus x plus cos pi plus x is equal to 0. We have to prove that it is equal to 0. Now, first of all, 3 pi by 2 plus x, that is 270 plus theta. It lies in the fourth quadrant. In the fourth quadrant, sign will be negative. Next is 3 pi by 2 minus x. It is 270 minus x. It means it lies in the third quadrant. In the third quadrant, sign also negative. Last one is a pi plus x. It means 180 plus theta. So again it lies in the third quadrant. Now take the sign of the function according to the quadrant. Now first of all, cos x will come same. Cos x, here plus sign is there. Now sine 3 pi by 2 plus x. Now it contains a line of pi by 2, so function will change. It will become cos x and as it goes in the fourth quadrant and sign is negative in the fourth quadrant, so minus cos will be there. Again minus sign as it is, sine 3 pi by 2 minus x. Now again it contains 3 pi by 2, so minus cos x function will be there. Then plus sign cos 180 plus x again comes in the third quadrant. So here pi is involved in the angle, so function will not change, only sign will change. So we get minus cos. Now when you simplify, here plus minus minus, here minus minus plus, and here plus minus minus. Now you can see that this cos x cancel with minus cos x, plus cos x cancel with minus cos x. So answer is 0. Hence proved. Let's take one more example. It is simplify cos x upon sine pi by 2 plus x plus sine of minus x upon sine pi plus x minus tan pi by 2 plus x upon cot x. We have to simplify and find its value. Now look at the first, pi by 2 plus angle. It means pi by 2 plus x lies in the second quadrant. Next is pi plus x. Pi plus means 180 plus x, so it lies in the third quadrant. Here pi by 2 plus x is there, so it lies in the second quadrant. So we have to apply the result according to the quadrant. Now first of all, cos x as it is, sine pi by 2 plus x. It is in the second quadrant as it involves pi by 2, so function will change. We get cos x upon cos x. Plus, now second one, sine of minus theta. As we know it is equal to minus of sine x. Here sine pi plus x, that is in the third quadrant. Because it involves pi, so function will remain same. So sine x, but in the third quadrant sine is negative, so minus sine x. Look at the third value. So tan pi by 2 plus x, it goes in the second quadrant. Tan changes to cot because tan is negative in the second quadrant, so it is minus cot x. And this cot x as it is. Now you can see here minus sign cancel with minus. Here minus minus will become plus. Now when you simplify, you will get cos x cancel with cos x 1. Then sin x cancel with sin x again 1. Third is cot x cancel with cot x again 1. So 1 plus 1 plus 1, it is equal to 3. In this way, we can simplify the expression. Students, now you are able to solve sums related to these types given in your SNAP homework. Before starting the work, you must go through the links guided in the SNAP homework. Rest we will continue in our next class. Thank you.